Hey, sweetie. Okay, I'm going to do number 5 from your homework. So the direction was to solve each equation by finding all roots, and I wrote down number 5. And that polynomial is 3x cubed minus 10x squared plus 10x minus 4 equals 0. Okay, so what we're going to do, we know that since the highest exponent here is 3, okay, then it's going to have it'll have 3 roots or 3 solutions or 3 zeros, all right? So we're looking for 3 different roots or 3 different solutions because that's the highest degree, all right? So I was talking to you about grouping these, but there's no way of grouping these, and especially because you're working in complex numbers now, complex solutions. So you can't just group it and factor it easily if some of the solutions are going to be complex numbers. So what we're going to use is the rational root theorem. I think that's what it's called. I can't remember exactly, but it's like to find possible rational roots, meaning find any root in here that's a rational number, something we can work with and break it down. Okay? So what we do is take the very first coefficient to the highest degree, make sure it's in descending order of the degrees, and then the one at the very end, the constant. Okay, so those are the numbers we're going to be working with. We're going to find the factors of each of those and then work from that. Okay, so I'm going to zoom in a little bit. So what we're going to do is find the factors of the coefficient to the highest degree, this first term. Okay, so we have a plus and minus 1. Let's start with the 1 here. And then a plus and minus 3. Those are the factors of 3 right there. Now let's go to this last constant, and the factors of negative 4 would be plus and minus 1, plus and minus 2, plus and minus 4. Those are the factors. Okay, and then I don't know if you remember your teacher talking to you about or talking to the class about the rational root theorem. That's where you take the P over the Q. So these are your P's right here. These are your Q's, and it's just P over Q. You don't even have to really remember the P over Q thing. Just remember the last over the first. Take this one over this one and put it into a fraction. Okay, so let's put all of these, the factors that come from the last one, all over this 1 right here. Okay, the plus or minus 1, just because it makes it easy. 1 over 1 is 1. 1 over negative 1 is negative 1. 2 over 1 is 2. 4 over 1 is 4. So then we get, from our P over Q, we get plus or minus 1, plus or minus 2, plus or minus 4 over the 1. Okay, so those are the first set over the 1. But now we have to do all of these over the 3 because those are possible rational roots as well. All right, which kind of look messy. We're just hoping that's not one of them because that would be a mess. So we're going to do plus or minus 1 over the 3, 1/3, then plus or minus 2 over the 3, which is 2/3, and lastly plus or minus 4 over the 3, 4/3. So those are possible rational roots that we get from using the rational root theorem. This one, all the factors over the possible factors of this first one here. Okay, so what you use is synthetic division, right? You remember with dividing polynomials. Okay, so what we're going to do is divide, and we're going to start with the easy ones, right? We're not going to go to the fractions just yet. Oh, actually, we don't even have to go there because I already tried it. So we're just going to start easy. Instead of long division, we already have a possible root. We're going to see if it is a root, by using synthetic division. So I'm going to go ahead and plug this 1 in as a possible root, and then I take my coefficients to my polynomial, right, which are 3, -10, 10, and -4. Set up my little synthetic division chart, all right, and 1 is the first root I'm trying out. That's the very first one. All right, so do you remember synthetic division? You drop the 3, multiply, put it right here, add them together, -7. So you multiply, you get a -7, you add, you get 3, you multiply it by the possible root, 3, add them together, -1. Nope, it doesn't work. Because if it was a root, remember I told you that finding a solution, finding the answer, finding the root, finding the 0, that's all the same thing. So if this was a root, then your remainder would be 0. That means it would go in evenly. And no, that doesn't work because your remainder is a -1, not a 0. So I already tried the -1, and that also didn't work. All right, so that was a no-go. I'm not going to go through that again. You can do that on your own if you want to try it. But I did try the 2 as a root,